Welcome back. In this section, we're going to discuss about the natural and man-made nanomaterials. Okay, first we're going to talk about the naturally occurring nanomaterials. The natural nanomaterials refer to any object that is already present or formed in the environment without human intervention. And it turns out that nature itself is a skilled nanotechnologist. Natural nanomaterials are abundant during Earth's formation and throughout its evolution over the past 4.5 billion years. It can be found everywhere in nature and are continuously forming within and distributed throughout continental soils, ground, the ocean, and the atmosphere. To our surprise, nanomaterials such as fluorine and graphene even have been discovered in space. Only with recent advances in instrumentation and metrology equipment are researchers beginning to locate, isolate, characterize, and classify the vast range of their structural and chemical varieties. When we take a closer look, nanomaterial plays a vital role in the geochemical and biogeochemical reaction and kinetics, such as the availability of elements in the ocean, the partitioning of metals in other aquatic systems, and the bioavailability and toxicity of many elements. Our drinking water, for example, is full of polydispersed nanoscopic and microscopic solid materials of irregular shape, usually in the form of calcium carbonate, calcium sulfide, hydrogen sulfide, and also various oxides of iron. Researchers estimate that soils are the most prolific generators of Earth's nanomaterials and that the ocean provides the largest collective reservoir of these materials. Natural nanomaterials are mainly produced by the following mechanism. The first is through volcanic ashes, formation of humic substances, through the desert storms, and through the biological nanomaterials. We're going to talk about these sources one by one. While hunting for nanoscopic material in the environment, one soon realized that a fair number of natural nanoparticles can be found in the volcanic activity, fires, or other types of combustion. The nanoscopic ash or soot particle is produced and are readily suspended in the air as a result of these activities. Volcanic ash cloud, for example, contains a wide variety of polydispersed nanoparticles with size ranging up to 200 nanometers and are chemically primarily composed of silicate and iron compounds. Humic substances are the compound or particles that are derived from a layer of ultra soft coal which has very concentrated source of carbon, and it actually is the most studied environmental colloid due to their trace metal binding ability. The formation of humic substances is a continuous cycle. The first part is the breakdown of organic matter into its basic component by decomposers like fungi, insects, and bacteria, along with the slow degradation of rocks and minerals by natural weathering and also rock-eating organisms. The second part of this cycle is the reformation of these broken down particles into a variety of chemical compounds collectively called humus. And eventually this compound will break down into molecules that are very chemically stable and resistant to further decay in the size of few nanometers to few hundred nanometers. The next main source of natural material is through the desert storm that produce iron-rich nanoparticles. Studies supported by satellite image reveal that dust storm in one region can migrate the nano and micro-sized mineral to thousands of kilometers away from their origin. Lastly, a number of biological processes are associated with the production of nanoparticles. The last main sources of natural nanomaterials that we're going to discuss is through biological nanomaterial. A number of biological processes are associated with the production of nanoparticles. It turns out that these microorganisms are created with the ability of a nanotechnologist. Organisms such as S. carnosus, S. aureus, and E. coli are able to produce homogeneous distribution of selenium nanoparticle which humans are currently exploiting for various applications such as to remove environmental contaminants, food supplements, and in the agriculture industries as the fertilizer.